All right, so looking at this question, who determined the actual mass of electrons? Okay, so the charge to mass ratio was determined by J.J. Thomson. So he discovered the charge to mass ratio, but Robert A. Millikan determined the charge on an electron. Charge on electron. So the answer is this. Alright, so looking at this question, europium has two stable isotopes. So we have this isotope with a mass of this and this isotope with a mass of this. So if the elemental europium is found to have a mass of this, so this is the relative atomic mass. So calculate the abundances. So total abundance is what? Is 100%, right? So we can therefore say that 151 EU and we have 153 EU. So the mass was given to be 150.9196 AMU, and for this we have it to be 152.9209 AMU, right? So we can therefore say that RAM, which is the relative atomic mass, to be equals to the summation of mass times abundance over the summation of the abundance, right? So we can therefore say that 151.96 equals to, so the mass is this and the abundance is this, right? So we have 150.9196 times x, so plus 152.9209, right, times 100 minus x over 100. So therefore we have that 15196 equals to 150.9196x plus 15292.09. We multiply 1 2, so minus 152.9209x. so we therefore have that, so let's use this part. We therefore have that when you evaluate everything, we have negative 96.09 equals to negative 2x. So we can therefore say that x equals to 48% and y equals to 52%. So this is the answer, option D. Alright, so looking at this question, given that the radius of an atom, so radius of atom equals to 10 raised to power minus 10 meter. So calculate the volume. So let's say the volume of nucleus is unknown, right? So the radius of nucleus is given to be 10 raised to power minus 5 times of radius of atom. So therefore we can say that volume of nucleus, so we're assuming that the nucleus is spherical, so volume is 4.3 4 over 3 pi r cube. So that's the volume for a sphere. So we have that 4 over 3 pi. So the radius is 10 raised to power minus 5 times 10 raised to power minus 10. So we have 3 here. So therefore we have that the volume of the radius is equals to 4.19 times 10 raised to power minus 45 meter cube. So option B. Alright, so this question states, who spearheaded the gold foil alpha scattering experiment? So that is Ernest Rutherford. All right, so let's look at this question. So the atomic number of bromine is 35. So which of the following is the correct electronic configuration of bromide ion? So bromide ion is basically 35 plus 1 electron. So that becomes 36 electrons. So we have that 1s, 2s, 2p, right? 3s, 3p, 3d. We also have that 4s, 4p, 4d, 4f, and we have 5s, 5p, 5d, and so on like that. So let's say this is this. We have this to be this, right? We have this to be this. We have this to be this, and we have this to be this. This to be this. So therefore, we can write the configuration as 1s, 2s, 2p, 3x, 3p, 4s. Then we go to d. So we have 3d. Go to p. So we have 4p, 5x, and then we move to 4d. We have 4d. We have 5p. So let's fill it with electrons. We have 36 electrons to fill in. So we have 2, 2, we have 6, we have 2, we have 6, 2, we have 10 electrons, we have 6 electrons, 2 electrons, we have 10 electrons. Everything here is 10. So 20, 30. So we have 38. And so we don't have to fill everything here. We don't have to fill everything here. So these are not needed. So since this is 35, this is 30, and we're going to 36. So we have this, the whole of this is 10, the whole of this is 10, so this is 10, so that is 30 plus this 36. So the electronic configuration is therefore option C. So looking at this question, which one gives the correct expression for charge to mass ratio of an electron? So the charge to mass ratio of an electron was determined by J.J. Thomson in his experiment. So we have it to be E over B square R. So it's the same thing as this. So we have it to be this. Alright, so let's look at this question. So boron consists of two isotopes. So we have this isotope and this. So if the abundance, so let's say that B and then B, so that's 10.013 and then 11.009. So if the relative atomic mass is not given here, so but we have that the relative abundance of this is 19.9%. So this will become 100 minus x, 100 minus 19.9%. So this should give us 80.1%. So relative atomic mass is the same thing as the summation of mass times abundance over the summation of abundance. So we can therefore say that RAM is equals to 10 point, this is the mass, 013 times 19.9, which is the abundance, plus 11.009 times 80.1. So we have this times this, so over 100. So this should give us 199.26 plus 881.82, everything over 100. So therefore we have that 1081.08 over 100, and this gives 10.8108. So option B is the answer. Alright, so let's look at this question. So what is the velocity in which an electron experiencing an equal magnetic and electric field moved in an electric field strength of this and the magnetic field strength of this? So in this question, we're given that the electric and the magnetic field strengths are equal. So we have electric field strength to be this, and we have magnetic field strength to be this. So remember, when they are equal, we have this and we have this. So this cancels out, right? So we have the velocity to be equals to E over B. So therefore we have that our E to be equals to 3.45 times 10 raised to power minus 3 Newton per coulomb, and we have our B to be equals to 5.41 times 10 raised to power minus 6 Tesla. So we have that our velocity to be equals to 3.45 times 10 raised to power minus 3 over 5.41 times 10 raised to power minus 6. So we have everything to be equals to 637.71 meter per second. So the right answer is D. Let's look at this question. So how many unpaired electrons are in the valence shell of bromine? So in which the orbital is this and this? So basically we have that bromine atom is 35, right? So we have that the electronic configuration of bromine to be this 1s2, 2s2, we have 2p6, we have 3x2, 3p6, 4s2, and we have 3d10. So this is 10, this is 20, this is 30. So we have to add 4p5. So this is the electronic configuration, and we can see that this is p orbital, right? So we have this to be this. So this is p orbital. So we have 1, 2, 3, 4, 5. So we are filling these 5 electrons there. So we have one unpaired electron. So basically one unpaired electron, right? And this is 4p. That's the orbital. So this is the right answer. Question: the ratio between neutrons present in carbon and silicon with respect to the atomic masses 12 and 28. So basically we have that carbon is this 12, so that is the mass number, the atomic mass that was given. So and we have its proton to be 6, right? So we also have silicon. So silicon is 28 and the atomic number is 14. So basically atomic number is the same thing as number of proton, and we have that proton to be equals to 6. So therefore mass number, right, is equals to 12 in the case of carbon. So therefore we have mass number to be equals to proton plus neutron. So we have our neutron to be equals to 12 minus 6, and that's 6 neutron. So also we have that we have the proton to be equals to 6. So the mass number is for this the proton is 14 rather. So the mass number is 28, which is this. So mass number is equals to proton plus neutron. So the neutron for silicon is 28 minus 14. So we have it to be 14 neutron. So the question says, what is the ratio between the neutrons present in carbon and silicon? So the neutrons in carbon is 6 and the neutron in silicon is 14. So when we divide this, we have 3, we have this 7. Alright, so let's look at this question. Which one represents an impossible arrangement? So basically we have that for the first option we have n to be equals to 3. So L is the azimuthal quantum number, and the ranges of L is basically 0 to n minus 1. So when n is 3, we can have our L to be 0, 1 and 2. We don't include 3 there. So the ml is basically the range of values. So it can be negative L to positive L, right? So because this L here is 0, so it just has one value, 0. So this has range of value, negative 1, 0 and positive 1. So this we have negative 2, negative 1, 0, positive 1 and positive 2. So and the next one is basically the ms, which is the spin. So spin can be positive 1 over 2 or negative 1 over 2 depending on its direction. So looking at the first option here, we have 3. Yeah, that's possible. We have L is 2, so that is also possible. We have m equals to minus 2, so this is also possible. And we have this, so this is also possible. So this is possible, it's not impossible. So let's look at the option B. So we have when n is 4. So when n is 4, L will be 0, 1, 2 and 3. So ml will be what? For this one 0, for this one negative 1 to positive 1, for this one negative 2 to positive 2. So for this negative 3 to positive 3. So and the spin can be positive 1 over 2 or negative 1 over 2. So 4, yeah, 4 is possible. So L is 0 is possible. So M, this is possible, and this is also possible. So this is also a possible arrangement. So let's look at C. Option C, we have that n equals to 3, right? So let's just use this one, A. So when n is 3, so L is 2. L is also possible to be 2. So M is 3. So you can see from here, ml, we do not have 3 here. So this is an impossible arrangement. So for us to look at this, let's look at the last one. So option D, we have n to be what? N to be 5. So therefore L will be what? 0, 1, 2, 3, 4, right? So ml will be, for this one will be 0. So looking at the option here, we have 5, we have L to be 3, possible, and ml to be 0. So that is possible also. So this is also possible, this is possible, and this is possible. So this is the impossible arrangement. The answer is C. So let's look at this question. Take Planck's constant to be this. So determine the frequency of radiation emitted when an electron moves from one energy level to the other, given that the difference in energy level is this. So basically, for us to calculate this, we just have to use this formula. H is equal to hv, where this is the frequency. So this is the Planck's constant. So this is Planck's constant, right? So therefore we have that. So we are told to calculate the frequency. So we're given that this is the difference in energy. So this becomes 33.125 times 10 raised to power 3 joules equals to, so the Planck's constant is 6.625 times 10 raised to power minus 34, so times velocity, right? So alright, so let's look at this question. The following are Dalton's atomic theory except. So matter consists of definite particles called atoms, which are subatomic particles. So I think this is out because Dalton's atomic theory states that matter are indestructible. Like Dalton did not mention that atoms are composed of subatomic particles. It was further experiment that modified this theory from Dalton's. So Dalton states that atoms are indestructible. So Dalton also states that all atoms of a particular element are identical in mass. So atoms combine in small number ratio. Yeah. So the answer is A, option A. So a scientist, while performing an experiment to determine charge to mass ratio of various gases using the Starch ray tube, so he found out that the ratio of charge to mass was constant no matter the gas in the tube. So the particle contained is electron, and that's right. So for this question, what value of subsidiary quantum number L are permitted? So when n equals to 4, right? So we have that our L to be L is basically 0 to n minus 1. So we have this to be 0, 1, 2, 3. So our ml, we don't need that basically. So we have that this to be the right answer. Alright, so let's look at this question. Which one represents an impossible arrangement? So n equals to 2, therefore L will be 0, 1, ml will be 0, -1 to +1, right? So this is actually right. We have 2, we have 1, and we have 0, because this is -1, 0, +1. So for option B, we have that n equals to 2, right? L equals to 0, 1, and yeah, 0, 1. We're not going to 2, so we cannot have 2 here. So definitely this is out already. So let's look at C, option C. So we have n to be equals to 3. So we have L to be 0, 1, 2, right? So 3 is possible, this is possible. So let's look at ml. We have 0, we have -1 to +1, we have -2 to +2. So this +1, so basically this option is right. So let's look at D. N equals to 3, right? Therefore we have that our L will be 0, 1, 2, ml will be 0, -1 to +1, -2 to +2. So this is also possible. So this is wrong. Option B. Let's look at this question. The relative atomic mass of S is this. So we have that RAM to be equals to 39.1. So we are told to calculate the relative abundance of X of this isotope of X in a sample of the element X. So basically RAM, relative atomic mass, equals to summation of
Each echoing step on the forest floor opens a world through an ancient